Hey kids, Miss Kulkarni here. In this video, we will talk about bonding and also how to calculate bond polarity. So here are the important bonding which you're going to talk about. Ionic, then covalent, and there is metallic bonding. Ionic bonding will be in ionic compounds, and covalent bonding will be in covalent compounds. Of course, metallic bonding will be in metals in the free state. How does the bonding occurs in all these compounds? For ionic compounds, it is transfer or exchange of electrons. For covalent compounds, they share and care. So it's sharing of the electrons. Let's find out how electronegativity can help us finding the bond polarity. So what we do is we find electronegativity difference, which is denoted as delta En. And this whole table which you got over here, that gives electronegativity values. And we take the values which are given underneath each of the element, and then we find the difference. The value of the difference will tell us if the bond is an ionic or if it is covalent. Not only that, but it will tell us if the covalent bond is a polar bond or a non-polar bond. So let's find out more about that. So here is the case 1. The electrons, of course, as you know, are shared equally, and that's why we call that as non-polar covalent bond. There is no competition between both the atoms. And delta En is always equal to less than 0.3 for all the non-polar covalent compounds. Case number 2. The electrons are shared unequally, and that's what we call as the polar covalent bond. One element is more greedy for the electrons than the other one. That happens sometimes, right? And then the delta En for that is going to be between 0.3 and 1.7. It won't be less than 0.3 or it won't be more than 1.7. Case number 3. And this is the ionic bonding. Electrons are not shared, but they are transferred. And they're transferred from metal to a non-metal. Usually, this bonding occurs between a metal and a non-metal, or sometimes this could be a polyatomic ion, which is negative. But the main point is delta En value will be always more than 1.7. So here's something I like to use. Instead of remembering the rules, I make use of this number line. So if that is, okay. So if you want, you can memorize these rules, or I am going to use this number line. And this is the 0 for my number line. And let's say maybe 0.3 comes somewhere over here, and 1.7 is coming somewhere over here. I'm just using a random scale there. And this number line represents delta En, that is the electronegativity difference. So if your value is anywhere below 0.3, what is it going to be? That will be a non-polar covalent compound. If your value is above 1.7 anywhere here, that will be an ionic compound. And if your value is anywhere between these 0.3 and 1.7, then what do we get? That's the one we get polar covalent compound. So that just makes it easier to remember how to relate delta En values with the bond polarity. Here are some examples for you. So if your molecular formula is fluorine, that is F2, look at the delta En. It's 4.0 minus 4.0 equals 0. That will be, of course, less than 0.3. And when it's less than 0.3, we have non-polar covalent bond. I'm going to give you a hint. Fluorine is a diatomic. So technically, all our diatomics will have delta En equal to 0. And which are those diatomics? I bring clay for our new home. Okay, next one which you got is H2O. Now remember, we are doing the delta En for each bond. So we are looking for a bond between hydrogen and oxygen. And it is a difference. So it doesn't matter which one comes first. The values are 3.5 and 2.1 and difference comes 1.4, which is between 0.3 and 1.7. So we end up getting that as a polar covalent bond. And then this is NaCl. So we get the value for sodium and Cl. Think about that, these two values. And then when we subtract those, we get 2.1, which is higher than 1.7. So that makes it an ionic bond. Are you ready for some practice? So let's begin. This is Li2O. That's lithium oxide. And you're looking for the values for lithium and oxygen. And here we go. I got the values 3.5 minus 1.0. So what is that? That is 2.5. Simple subtraction. If it is 2.5, it is greater than 1.7. So what is the bond type? It will be ionic. Let's do the next one. I am looking for the bond between N and Br. Yeah, we may have 3 bonds, but we are going to talk about just each bond polarity. So for nitrogen and bromine, the bond polarity difference is 3.0 minus 2.8. And how much is that? That is 0.2. 0.2 is, of course, less than 0.3. Well, no brainer. And then that means it is going to be a non-polar covalent bond. Let's do one more. CF4. So you're looking for values for carbon and fluorine. And using my table, I got the values 4.0 and 2.5. So the value comes 1.5. Definitely this is between 0.3 and 1.7. So that means it will be a polar covalent. That means whatever number of bonds we got, all those bonds between carbon and fluorine will be a polar covalent bond. We will talk more about is the polar bond responsible for making the compounds polar or not in our next videos. But anyway, I hope you guys know how to calculate electronegativity difference delta En using the table, and using the number line which we got over here, we can figure out if the bond is either non-polar covalent or it is polar covalent or is going to be an ionic bond over there. So guys, I hope you enjoyed the video and I will see you again in next video. Until then, bye-bye.